I am Malvika Gupta, Assistant Professor in Applied Science and Humanities Department. Today I am going to discuss the topic about the analysis of linear search and binary search. First of all, let me introduce what is the analysis. What do we mean by analysis? Analysis means that we need to find that what is the complexity of an algorithm, whether it is the space complexity or the time complexity. Complexity is a kind of a function which actually determines that how much storage space is required by a program and what is the execution time required by a program for execution. So before starting this, let me tell you that how we find out the execution time, because in this fast moving era we don't have the problem like how much space we are having, but we are bounded by that all the work should be done with a nick of a time. So time complexity is most important in present scenario. First of all, let me tell you that what is the increasing order of time complexity. Like what is the minimum time complexity and what is the maximum time complexity. Every coin has two things, heads and tails, and with this we are also having the minimum complexity and the maximum complexity. So I am writing out the order of the complexities in ascending order. This is the order of the complexity. Order of 1 is the minimum complexity of any algorithm, and order of 2 raised to the power n, which is the exponential one, is the highest, the maximum time complexity. Let us first discuss about the complexity of the linear search. So before starting with the analysis, let me tell you how linear search works. Let us say, what do we first of all we should know, we know that searching means finding out an element from the array. Array, you all must have known about it, very much familiar with this word. Array means the collection of homogeneous type of data. It means the similar type of data referenced under one name is known as array. So I am going to find out a number, let us suppose 2, in an array which is 1, 2, 3, 4, 5. This is a 5 element array, and I am going to find out this number, search this number in this particular array. It might be possible that with this there may be two possible conditions, which is one is the best case and the second one is the worst case. In the best case scenario, it might be possible that whichever the element we are searching in an array might exist at the very first position of an array. So if we find out this particular element at the very first position, at that time the time complexity will be order of 1, because we took only 1 second just to find out this particular element in an array. But in case if we don't find this particular element in an array after traversing throughout the array, then it means that we are traversing 1, 2, 3, 4, 5, all the 5 elements, and still the search is unsuccessful. In that case, the searching time will be order of n. It might also be possible that this element may be occurring once at the second position and once at this position. So we cannot stop searching our element on this particular position wherever we first find out the element at the very first time. Might be possible that this particular element might be occurring in other part of the array also. So we are searching like this. 2 will be compared with this one. If it is matched, then okay. If it does not match, then we will move to the next point. If it is matched, then it will track the location and it will count it as 2. Then we'll move to the next position, then to the next, and then to the next. So we are finding this particular element at the 2 positions, so it will track the position like 2 and 4. So this is how we are working in the linear search algorithm. So this time, but we need to search this element in throughout the array. So we are traversing the whole array. So if this is the array of 5 elements, and to find out this particular element, we have to check, or we have to compare this element with each and every number which is present in the array. It means it is taking let's say 5 seconds of time. So if in general we can say that if we are having the n elements in an array, so to search the n element in an array, it will take order of n time, because it is comparing the this element is compared with each and every element present in the array. So this is all about the analysis of the linear search. Now let's move to the next analysis of binary search algorithm, which is quite more efficient than the linear search, as it is taking order of n time, and I have told you that this is the increasing order. So we are now dealing with the binary search algorithm. Now in case of binary search, binary, as its name suggests, the first two letters which makes the term bi. So bi means 2. It means we are dividing our array into the two parts or in the powers of 2. So that time, now let me take an example of an array. Let's say this is an array of 7 elements. Odd number of elements are here. And I am searching for the element which is 2. Right? So first of all, in binary search, what we do, we are supposed to find the middle element of an array. Middle element will be found. This is the beginning of an array and this is the end of the array. So middle element of any array will be found like beginning plus end divided by 2 is the middle element. So it will be 0 plus 6 divided by 2 is equal to 6 divided by 2, it is 3. It means the element occurring at the third position will be the middle element. So this 4 is the middle element of an array. Now I have to compare this 2 with this element 4. If this is smaller than this middle element, then we will only traverse this part of the array, which is called the left part of the array. And if this element number 2 is greater than the middle element, then we will search this part of the array, which is the right part. So if the element, we can summarize it like this: if the element, searching element, is less than the middle element, we traverse only the left part. If searching element is greater than the middle element, then we traverse only the right part. Now you can easily find out that why binary search is better than the linear search. In linear search algorithm, we have to traverse the whole of the array to search a single element. But in the case of binary search, we are dividing our array in two parts and we have to search the either part according to the comparison with the middle element. Now as this is written as, now we are dividing the array in the powers of 2. As you can see, I have taken this example, the array of 7 odd elements, 0 plus 6 divided by 2, it will become 3. So it means the position third, this is representing the position, and the position third is containing the number 4. As you all are very well aware that array starts from the index 0. So it will go to 0 to n minus 1. So if I am taking the array of 7 elements, then it will move from 0 to n minus 1, that is 6. So now I have to compare this if I need to search the element 2. Searching element for my algorithm is 2. I need to compare this 2 with 4. So 2 is less than 4. So there's no need to go to the right part of the array. I only traverse only this part of the array, which is 1, 2, 3. Now this array is of 3 odd elements. Now once again I need to find out the middle element of the array, which will be 1. This, which is the middle element of the array, is occurring at the position 1, which is 2. Now I can compare 2 is less than 2. No, 2 is less than 2 is not possible. 2 is equal to 2. 2 is equal to 2. It means I have found the element by only looking at this element, these three elements. So total number of elements I have to look in just to find out this element, whether this element occurs in the array or not. I have to only look for 4 elements, these 4 elements. So in this way we can make a kind of a summary that how many elements I have to check to find out a particular element in the odd array. So this will be like this. If I am searching an array of 7 elements, then I need to check only 4 elements. Array of 7 elements, numbers to be checked are only 4. If it becomes 15, then the numbers will be how much? Then the numbers will be 5. If it is 31, then the numbers will again be 5. So this is the kind of a summary which we can make like this. 2t raised to the power minus 1, and t is the number. So it will be 2 raised to the power 5 minus 1. 2 raised to the power 5 is 32 minus 1 is equal to 31. So only 5 elements I need to check when I have to search an element in an array of 31 odd numbers. So once again, now comes the question that what is the complexity of this binary search? If I need to search n elements, so how much time it is going to take? We have made an equation like this. N is equal to n number of elements I have to search in 2t raised to the power minus 1 time. So it will become n plus 1 is equal to 2 raised to the power t, and then this is after multiplying by log on both the sides, it will become log 2t, 2 raised to the power t. It is a simple mathematics. Log n plus 1 is equal to t log 2. This is the formula. The log we are taking, it is of base 2. So log base 2, log n 2, it will become 1. So this will be t multiplied by 1, log base 2 n plus 1. This will be t is equal to log n plus 1 with base 2. This is the complexity of binary search. That's how when we are taking all the searching algorithms, and if we are searching an element, or if we are taking a smaller part or a part of a particular structure, then every time the complexity will become order of log n. So I hope this is the glimpse of binary search and linear search. Analysis of linear search and binary search might be possible. Next, you can do the same as in the case you can search, or you can find out the analysis of sorting algorithms also. Thank you.